In this video, you will learn about the two types of cross-sections that are used in civil construction. The cross-section view is a look or slice cut perpendicular to the center line of a project, in other words, at right angles to the profile view. In some cases, the view may be specific to a single location on the project, and in that case it will be identified by the specific station number. Realize also that there are two distinct types of cross-sections used. The first type is known as a typical section. It illustrates what to build in a general sense. Here's a small example of a typical, which we will look at in more detail shortly. As you will learn, the typical establishes uniform criteria in terms of critical dimensions and slopes. The second type of cross-section is the actual section, which applies the criteria of the typical to a specific location identified by stationing. Note that the actual sections will always have a grid and show precise elevations. And again, we'll see more of the actual in just a minute. So here's a larger example of that same typical cross-section for a road. Let's see what it tells us about the work. Remember that a typical illustrates what to build in a general sense. First of all, the typical will usually be labeled as such, and if you look over here it says typical 2-lane road, and it even goes so far as to tell us which part of the road that this typical applies to. And note up in the center here that we have a center line indicated on this typical from top to bottom, and what we'll see is that the left side of this typical, left to center line, is really about how the roadway would look in a cut situation, and the right side represents how the road would be built in a fill situation. Now, a couple of other things are used here. In an earlier video we talked about slope ratio, and if you'll note here, they've used the slope ratio convention to define the shape of the drainage ditch on the cut side. They've also used it to define the slope on the fill section going down to meet the natural ground. And they've also used the percent grade convention to define the much flatter pitch or slope or gradient for the finished roadway surface. Okay, let's move on and look at an actual section then based on this typical section. Remember, we said that a cross-section is perpendicular across the center line at a specific location. Looking at this plan in profile, we can see that our actual sections will be located at station 35 plus 50. If you have not viewed the video on plan and profile, you might find it helpful at this time. And on the profile, we can see that our actual section will be in what we would call a cut area. Okay? That is that the soils must be excavated from the existing grade down to the proposed grade. Okay, so let's look at what the actual section at this station looks like. And let me get a highlighter for this. I think it'll be helpful. So here we have our actual section for this very specific location, station 35 plus 50. If we look close, we can see that both specific elevations are required and the distances from the center line that are unique to this location are shown. So let's start with the pavement. Here's the pavement to be built, and the edge of the pavement, both left and right, is going to be 13 feet left minus 13, or 13 feet right, no minus sign, and the precise elevation at this edge you can see is given to us 740 plus 16, and in this case 740 plus 49. Now, in addition, we're in a cut situation. Remember, here's our existing ground, so we're going to have these ditches we talked about on either side, and the bottom of the ditch, the very V at the bottom, is called the flow line. That's abbreviated FL, and the flow line from the center line is 41.23 feet, and the elevation is 735.6 feet. And again, This ditch is higher, so it's closer to the center line, 33.6 feet, and again the elevation is given. And where the cut slope then meets natural ground, we have the distance and elevation, and the same thing on the left side. Well, this is entirely in cut, so let's just take a look back to our typical section and understand how this applies. Now, the brown line approximates our existing ground elevation that we saw earlier. And remember that this section showed about the center line how the work would be built both in a cut and a fill situation. Well, in this case we are entirely in cut, so the left side of the typical also applies to the right side for this location. Let's look at another example. Okay, same road, but at this location, station 53 plus 50, we see that we are in a fill situation. Proposed grade, existing grade. And note also that we have a ditch running on the left side of this road to this box culvert. Let's look at the actual section. Once again, we can see how the typical template on top here has been applied to the specific elevations and distances, edge of pavement, and our little ditch cut here, and where our fill slope meets actual ground. Also notice that this part of the road is on a curve, and that super elevation, to you NASCAR fans, that's banking, right? Super elevation has been applied to the pavement, and we can see that 707.89 on the low side, 708.93 on the high side. Okay, time to summarize. We learned that cross sections are views perpendicular to the center line of the linear work, and that there are two types of cross-sectional views: typical cross sections and actual cross sections. A typical illustrates what is to be built in a general manner, and the actual illustrates what is to be built at that specific location in a very precise manner.